All right, mathletes, here we go. Chapter 3, parts C and D, factoring by greatest common factor. So by factorization, it's the process of writing expression as a product of its factors. So before we were working on expansion, where we were distributing things and getting terms such as this, now we got to remember that factorization is the undoing of that process in writing things where we had sums before, but now writing things as products. Okay, so as we're starting off factoring here, we're just looking for greatest common factor. So what factors into all the terms? So for example 1 here, when I look at 6x squared and 4x, I look at my numbers and I know 6 and 4, the greatest factor they have is 2. I look at x squared and x, and the greatest variable factor is x. So as I factor that out, I think to myself, 2x times what is going to give me 6x squared? Well, 2x times 3x will give me 6x squared. Now for the second piece, 2x times what will give me a positive 4x? Well, that's just a plus 2. And I can visualize that that is going to be equal to this, and that 2x times 3x is going to be equal to 6x squared. So this is now my final factorization, where I'm writing it as the product of two terms is going to be equal to that. All right, for example 2, I look here and now I have cases of negative signs. Since they both have a negative 2 as a possible factor, I factor that out. And again, I can factor out an x here because they both have an x. So negative 2x times what is negative 2x squared? Well, I just need to multiply that by x. Negative 2x times what is negative 4x? Well, that's just going to be a plus 2. So there is my two factors that will give us that term. So I'm done at that point. Let's go to example 3. So example 3 here, we want to fully factorize these terms. So at this point, if I want to factorize it, again, I'm looking for common things. So here, I notice that there's an x plus 1 here and an x plus 1 here. So if I factor that out, I'm sorry, it's a plus 1, not x plus 1, but I factor that a plus 1 out, well, what am I going to get left with? So with this first term there, a plus 1 times what will give me that? Well, I just have to have a negative 4 there because I've already factored out that a plus 1. Now, the a plus 1 times what is going to give me this term? Well, I need to have this piece here. So this is a plus 2 there. So we have factored that there, but I want to actually make sure I can simplify as well. So this is just going to stay as a plus 1. But here, notice I have a minus 4 and a plus 2. It's a string of sums, so I can combine like terms. So negative 4 plus 2 is going to be a negative 2. And I have a plus a here. And I have fully factorized those terms. Let's look at example 4. So in example 4 here, this is bringing in the difference of two squares. So remember in previous units, we looked at that if we have an a and an a, those are the same terms, and a b and a b, but yet they are different by their signs. It's when we double distribute them, we end up getting this as their sums, a squared minus b squared. And it's called the difference of two squares. One square, two square. So what we want to do is now we want to be able to take those difference of two squares and go backwards and find their two factors, two things that multiply together. So in order to do so, I'm going to ask myself, I'm going to take the square root of both terms, or ask myself what times what is 4? Well, what times what is 4 is 2 squared. Now, what times what is negative 9y squared? Well, that is going to be, I'm going to leave the negative sign. I'm not going to worry about that. I know it's the difference, but I'm going to take the square root of 9y squared, which is going to be 3y. Put it in parentheses because that's the square root of that entire term. I know that 3y squared, the quantity 3y squared is 9y squared. So now, using my rule up here, I know that this will simplify into 2 plus 3y, and 2 minus 3y. And that's my fully factorized form. Just to verify that that's correct, we can check our work. Okay, so I can do 2 times 2 and I get 4. 2 times negative 3y and I get negative 6y. 3y times 2 and I get plus 6y. And now 3y times negative 3y and I get negative 9y squared. And remember, these middle terms are opposite of each other. They drop out and I just get 4 minus 9y squared. And now I have checked my work to verify that these are truly their factors of 4 minus 9y squared. Let's look at example 5 now. Example 5 here, we have a grouping of terms, and at first things don't look exactly right, so I'm going to rearrange these. So by inspection I see that this is 3ab, and I have a d here. That's not so useful, but I do have a b here. And where this is 3ad, I have a d here. So what I'm going to do is I'm going to kind of group like terms. So things with b's I'm going to group together, and things with d's I'm going to group together. So the things with b's, it's 3ab plus b is there. And then I'm going to group the plus 3ad plus d there. So now I have some similarities, just rearranging. We know that with summations, because of the commutative property, we don't care about the order, just because 2 plus 3 is 5 and 3 plus 2 is 5. The order of sums do not matter. So now I'm going to just look at these first two terms. Well, what do those first two terms have in common? They both have a b, and that's why we grouped them like that. So now I can factor out that b, and now what's left? B times what is 3ab? Well, 3a. B times what is b? Well, that's just going to be a 1. Okay. Now for the next piece, I'm going to do the same thing. I'm going to recognize that they both have a d in common. I factor that out, and I get a 3a plus 1 here. Well, this is very convenient because now I can look at and say that now both of these terms have a 3a plus 1 and a 3a plus 1 as similar terms. So I'm going to factor that out, 3a plus 1, because they both have that in common. Now, 3a plus 1 times what is this piece? Well, there's a b there. b times this will give me that piece. Now, same thing here, plus 3a plus 1 times what is this term? Well, it's got to be times d. So those end up being my final factorization. Okay. Let's look at our last two examples. So similarly, we are going to, how we factored the ones before, we're just going to identify our first two terms, and we're going to factorize our second two terms. Okay. And then we're going to do one more factorization after that if we have things in common. So for the first two terms, I again just ask myself, looking at those independently, what do those two terms have in common? Well, they both have an x. When I factor that x out, I'm left with an x plus 2. Similarly, I'm going to do that with the second two terms. They don't have an x in common, but they both have a factor of 5 in common. When I factor that out, it's x plus 2. So when we're factoring four terms like this, quite often we're going to get two terms after we factor out here that are the same. So again, what we're going to do is we're going to factor that out. Okay, and so when I'm thinking about this, x plus 2 times what will give me that term? Well, that's going to be times an x. So this times this will be that if I'm thinking about the reverse operation. So for the second one here, x plus 2 times what is 5 times the quantity x plus 2? Well, that's going to be a plus 5. Okay, and now I have factorized this because I have the product of two terms. Okay, our last example here, example 7, I'm going to do a similar thing. Only look at my first two terms. Well, again, they both have an x. I factor that out, and I get an x times x is x squared, and x times plus 3 is going to give me that term, because I'm thinking what times this is going to bring me back to this term. Okay, again, I'm going to look at my second two terms. And I notice that both those terms have a negative involved, so I'm going to factor out a negative. And 4 and 12, a factor is going to be, well, it ends up being negative 4 times the quantity. And then negative 4 times what is negative 4x from up here? Well, it's going to have to be multiplied by x. Negative 4 times what is going to be negative 12? Well, that's going to be a plus 3. Again, I recognize that this is the same factor as that, so I'm going to factor that out. So I get an x plus 3, and then I say x plus 3 times what is going to give me that term? Well, I need an x. And then for my next one, x plus 3 times what is going to give me that? Well, I need a negative 4. Okay, that concludes our notes tonight on factorization by greatest common factors. Highlight any questions you have and bring them to class tomorrow.